We're going to start off our discussion for stoichiometry by looking at types of chemical reactions. So, as a review, we need to remember that we start off and we have reactants, an arrow sign, which means yields, and then the products come. So, reactants will always make our products. Also, some new information for you. We have 7 elements that, when we find them in nature, will be diatomic, which means that there are 2 of them when we find them. So you're used to probably hearing or seeing that oxygen is always written as O2, and that's because it's one of the 7 diatomic elements. So our 7 diatomic elements are H2, N2, O2, F2, Br2, Cl2, and I2. And those will be the 7 elements that you need to remember. So if they show up in an equation, they're always a 2 after it if it is the free element only. If it is part of a compound, we leave it alone. The other thing that you'll notice is I'll write out the formulas, and when we go to put them on both sides, we do have to put the formulas in correctly. So we are going on the knowledge that you already know how to balance the equations and write these things down correctly for the names. Now, the 5 types of reactions that we'll look at, the first of those is a synthesis reaction, which is characterized by 2 or more free elements making a single compound. So some examples of those, if we take H2 plus O2, and it will make H2O. And those 2's in front of there are called coefficients that we'll talk about next time. We also have Na plus Cl2, which will make 2 NaCl's. And that is how salt would be produced, because NaCl is what we commonly think of as table salt. A decomposition reaction is a reaction in which we have one reactant which will make 2 or more products. So we start off with a single compound, and it makes 2 or more products, which can be free elements or a free element in a compound, or even possibly 2 compounds. So if we start off and we want to decompose salt, so we can take NaCl, which yields Na plus Cl2, because chlorine is one of our diatomic elements, and then we put the 2 N's to balance it. The next one is potassium chlorate, KClO3, and it is a special reaction that we'll talk about in the future, that we have that it makes KCl plus O2. And then when I balance those with coefficients, you'll see that I put a 3 in front of the O2, a 2 in front of the KCl, and a 2 in front of the KClO3. And like I said, we'll talk more about special decomposition reactions. Single displacement reactions, I believe your book calls it single replacement, but that involves a free element and a compound, which will make a free element and a compound. And simply what happens is that the free element will either be a metal or a nonmetal, or in our case, we learned them as cations and anions. And if it's a cation, it trades places with the cation, and if it's an anion, it trades places with the anion. So in the first example, we'll find that we have a free element, Na, which is also would be considered a metal or a cation for us, plus KCl. Now the Na and the K are the same thing. They're either both metals or they're both cations. And then that should make NaCl plus K, because the Na and the Cl will trade places. As you can see here with the red circle, the Na and the K will trade places. In the next example, we'll look at what happens if we have the free element as being the anion or a nonmetal. Now remember, when we write down our compounds, it's always cation, then anion, or metal, then nonmetal. So in this example, I have lithium bromide plus fluorine, which is listed as F2, and that's going to make lithium fluoride and bromine, and both the fluorine and bromine are diatomic, that's why the 2's are there. So the Br is going to trade places with the F, and that's what happens in a single displacement reaction. We have two things trading places. And then both of those are nonmetals, so the nonmetals would trade places. In a double displacement reaction, or as your text calls it, a double replacement reaction, we have two or more compounds reacting to form two or more compounds. And so again, all that we'll look at is, once we write it down, is we'll trade places with either the metal or the nonmetal, or we could state that the cations will swap places or the anions swap places. So in this case, we're going to have some sodium chloride, NaCl, plus potassium bromide. And so the Cl and the Br can trade places, or the Na and the K trade places. So we end up with NaBr plus KCl. Now in the second reaction, we'll have Pb and I think I'm going to switch this to PbNO3, 2, which would be lead nitrate, plus potassium chloride, and that's going to make some lead chloride plus potassium nitrate. So you'll see that I switched the nonmetals again. Now it's PbCl2 because the lead has a +2 charge, and so when we flip the charges, then they balance out. And a hydrocarbon combustion reaction is the last one that we'll look at. A hydrocarbon is anything that contains hydrogen and carbon, and combustion indicates that we have to react it and catch it on fire. So in order for something to burn, we have to have oxygen. So hydrocarbon combustion plus oxygen will always make the same products, which is carbon dioxide and water. So anytime that you see or I say some hydrocarbon burns, we'll have to know that we have to have oxygen as a reactant, and it always produces carbon dioxide and water. So in this first example, I have CH4, which is methane. So this is a reaction that happens when we catch our Bunsen burners on fire and we light a flame. So CH4 plus O2 yields CO2 plus H2O. And then I balanced them.